Hi, this is Dr. S, and this is the second video of Aromatic Chemistry for OCR A-Level. At the end of the first video, I gave you the molecular formula of C6H6, and I asked you to come up with some ideas for the structure and what that might look like. Now, that's quite difficult, so I wonder if you managed to get some. I'm going to go through a few options, but firstly, how do you actually work out what sort of thing would be in that molecule? Well, particularly with hydrocarbons, if you get an unusual hydrocarbon, what you can look at is what formula the alkane would have for that many carbons. So for 6 carbons, our alkane would be CnH2n plus 2, which would be C6H14. That's the alkane. This is clearly not an alkane. It's got fewer hydrogens than the 14. So what we need to do is work out how can we reduce that number of hydrogens. Now, there are a few things you can do to reduce the number of hydrogens in a molecule. If you think about alkenes, alkenes have a general formula of CnH2n. In other words, 2 fewer hydrogens than an alkane. We should know that the alkene for C6 would be C6H12. We've removed 2 hydrogens by replacing 2 of them with a double bond. What we could do is then add other things in order to reduce it further. So if, for example, you had hexane, C6H14, that's an alkane. One example of the hexenes there, which would be C6H12. What you should probably have seen at year 12 at some point is cyclohexane as well. 6 carbons arranged in a hexagon. The formula for that would be C6H12. So there are 2 things you can do to reduce the number of hydrogens in a molecule. You can add additional bonds between carbons, or you can form the carbons into a ring. Now, if we think about the difference between C6H14 and C6H6, we need to lose 8 hydrogens, which means we need 4 things that can reduce the number of hydrogens. Could be double bonds, could even be triple bonds, or rings. So some examples of structures you may have come up with might be these. 6 carbons in a line, but then with triple bonds perhaps between there. If you look there, I've added 4 additional bonds between the carbons, so I've reduced the total by 8 hydrogens. If I now fill that molecule up with hydrogens, 1, 2, 3, 4, 5, 6. That would be a viable structure. Similarly, I could have the carbons in a straight line again, but this time my triple bonds here. Again, I've added 4 additional bonds, so by the time I put my hydrogens on, I get C6H6. I may also have used rings. So I could have, for example, 5 carbons in a ring, which reduces it by 2 hydrogens. 1 extra carbon therefore outside the ring. Because I've already got 1 ring there, I need to add 3 additional bonds between carbons. So it could be, for example, 1 there, 1 there, 1 there. And if I now add my hydrogens in, 1, 2, 3, 4, 5, 6. So they are 3 possible structures. Another one that you might have come up with, I'll do it on this side of the page, is 6 carbons in a ring. So much like our cyclohexane here. But similar to this one, I'm going to need 3 additional bonds between carbons. So it might be there, there, and there. So when I add my hydrogens in, there are 6 hydrogens. Now this one is the closest representation to what benzene actually is. Well done for getting any of those. But that's actually not how we would draw benzene in the A level. So what I'd like to do now is to recap 3 words from year 12 before my next video. Those 3 words are aliphatic, alicyclic, and aromatic, and you should have met them when we were talking about hydrocarbons in the first place. I'd like to go and have a look at that before video 3, where I will then be asking you to determine whether structures are aliphatic, alicyclic, or aromatic. Okay, I'll see you then.